In this session we will learn partition pattern. Partition pattern is nothing but moving your data into different categories. Let's take a Stack Overflow example to demonstrate partition pattern. The problem given here is, given a set of user information, partition the records based on the year of last access date. It means all the users whose last access date is 2008 should be grouped in one file, and all the users whose last access date is 2009 should be grouped in another file. Similarly, it should be done for all the years. We have already seen the user data set. Let's check it again. Here is the last access date field. Using this field, we can determine when was the last time a user accessed Stack Overflow website. And then we can divide the users based on the year in this field. Since we have to group all the records by the year of the last access date, our output key will be the year in the last access date. Let's go back and see how partition is done. We have data from 2008 to 2014. So 7 output files has to be created. That is, one file for each year. Also, we know that by default there will be one output file from each reducer. Since we need 7 output files, there has to be 7 reduce tasks. Hence we need to set number of reduce tasks to 7. Now how do we partition the data such that all the records whose last access date is 2008 goes to one file, and all the records whose last access date is 2014 goes to another file? This is where we have to modify the default partitioner class. Let's first see how a default partitioner class looks like. This is how it looks like. GetPartition function is the function where the logic is returned to get the partition number. By default, it is computing the hash of the map key and then doing a modulo of the number of reduced tasks. If we use the default partitioner, then the user records will be shuffled among all the 7 reducers irrespective of the last access date. And we don't want our data to be shuffled. We want our data to be organized or categorized such that all the records with the same last access date goes to one file. So definitely we need to write a custom partitioner. Custom partitioner must look something like this. If the map key is 2008, that is if the year of last access date is 2008, then don't do any hashing and modulo. Simply return 0. So that all the records whose year of last access date is 2008 goes to first partition, and which in turn goes to the first reducer. Similarly, if the key is 2009, then return 1. So that all the records whose year of last access date is 2009 goes to the second partition, and which in turn goes to the second reducer. In this way, by overriding the getPartition function, all the records that belong to the same year will go to the same partition, and in turn go to the same reducer, and finally will go to the same output file. So the conclusion here is, year of last access date is the key. Number of reduced tasks should be 7, and we need to override default partitioner. Let's understand the code now. Here is the driver code. We are setting number of reduced tasks to 7. Also, we are setting the custom partitioner class by using setPartitioner class API. Also, we are setting the minimum last access date year to 2008. That's because our dataset contains data from 2008 onwards. This is used in the getPartition function. Let's see the custom partitioner class. Custom partitioner must extend the default partitioner class. Since map output is partitioned, map output data type must match the partition data type. Hence, the data type of the key is int writable and the data type of the value is text, where key is the year of last access date and value is the user record. In the getPartition function, we are subtracting min last access date year from each year. That is, 2008 minus 2008 will return 0, and hence it will go to the first partition. And 2009 minus 2008 will return 1, and hence it will go to the second partition. Similarly, 2014 minus 2008 will return 6, and hence it will go to the last partition. Let's see the mapper function. As usual, we are parsing the XML user record. Then we are extracting the last access date field. From the date field, year is extracted. Finally, year is set as the output key and the whole user record is set as the value. Let's see the reducer code. Reducer code is very simple. Here we loop through all the user records and output it as it is. We are not writing the output key here. That is, we are not writing the last access date year. Because for each year, we are creating a separate file. So writing the year inside the output file is unnecessary. That's the reason the data type of output key is null writable. Also, we are using text output format as our output format. In text output format, key and value are separated by a tab character. Since we are not writing the key, every record in the output file will start after a tab space. So we need to get rid of this tab space. For that reason, we are also setting the separator to null in our driver code. So now only user records will be returned to the output file. Let's run this program and check the output. Since we need 7 reduce tasks, we need to run this program on the Hadoop cluster. So let's create the jar file using Maven tool. Now let's run the program. Let's check the input file. Here is the input file. Input file size is around 660 MB. So 6 input split will be created. As a result, 6 map tasks will be created. Let's check the map tasks and reduce tasks of this job. 6 map tasks are created to process 6 input split. 7 reduce tasks are created as configured. Let's check the output. Seven output files are created, that is one file from each reducer. Let's check the first file. It contains all the user records whose last access date is 2008. Second file contains all the user records whose last access date is 2009. Similarly, last file will contain all the user records whose last access date is 2014. Obviously, there will be more users whose last access date is 2014. Hence the size of the file. That was all about partition pattern. Thank you for listening to this session.